Basically, Wireshark is a network monitoring tool, or to be precise, it is a packet monitoring tool. So it is used to monitor every packet that is sent from your PC to a specific destination, and even the replies that come from that destination to your PC. And it is not bound only to your PC. If you're connected to a network, then you can actually visit all of the traffic or all of the packets that are coming inside that network from some other PCs to a destination, and from those destinations to those some other PCs. Anyways, simply open up a terminal and simply type in Wireshark to open that up. Now if you do that, that is going to open up this Wireshark GUI. However, there is another way of opening Wireshark. Now for that, you would have to simply click on this top left Kali Linux icon and then come over to the 9th tab and choose Wireshark. This is also going to open up the same GUI for Wireshark. Again, if you want to visit the manual or the user guide for Wireshark, then simply type in the command man and search for Wireshark and then hit enter. That is going to show you the name, the description, and so much more. So as you can see from the description, it says that Wireshark is a GUI network protocol analyzer. So the keyword over here is that it is a network protocol analyzer, means that if you're connecting to a Wi-Fi network, which currently, since we are using the virtual machine, we are not connecting to the Wi-Fi, we are actually connected to an Ethernet, because the Wi-Fi connecting to our laptops or CPUs is being transmitted to this virtual machine as an Ethernet connection. But we don't have to worry about that. I mean, if you really want to connect to a Wi-Fi network, then you would have to connect an external adapter to your PC so that you can share it inside this virtual machine as a Wi-Fi adapter. Anyways, so it is a network protocol analyzer. Now it lets you interactively browse packet data from a live network or from a previously saved capture file. Now all we are concerned with is that it allows you to browse packet data. So simply open up Wireshark. Now let's talk about the GUI. On the very first screen, you can see all of these listings and this tiny little graph. So basically all of these listings are the ones that you can monitor. So as we're connecting to the Ethernet, so it says H0 and then any would mean like all of the network devices that are connected to your PC. Then you have loopback, and then we have the Bluetooth monitor that you can use to monitor the packets sent over a Bluetooth connection. But we are not concerned with that. All of the packets work in the same way, so going over to the Ethernet one would give us a better image. So simply choose Ethernet, and you can see these graphs. It means that there is some kind of activity within this network. So simply double click on it to open up the H0 capturing mode. Now, after you have selected Ethernet 0, you get this page. Now in here we have 3 different tabs. First of all, we have this tab where we can see all of the packets that are being sent to this network, which we are connected to using the H0. After that, we have tabular dissector of each individual packet. And then we have this third tab, which is basically the data of the packets. And then we have other options like analyze, statistics, telephony, wireless, and so much more, but we are not concerned with that. For this course or for this basic introduction, we are only concerned with these 3 tabs and these 2 buttons. Now the very first icon that looks like the fin of a shark is actually to start capturing packets, and the second one is to stop capturing packets. We don't want to keep the capturing enabled for a long period of time because we would capture a really large amount of packets and we won't be able to dissect it for our needs. So that is why it is pretty useful to stop capturing after you have done going over a particular website or a particular network. Now once you have stopped capturing a network, you would see this whole list of the packets that it had captured within that time period. For now, I'm just going to explain a few things, and then in the next video I'm going to head over inside the package and how to read data from inside the packet data. First of all, this number tab is actually the number of packets that the Wireshark has captured. Basically it is their ID. And then we have the time column. This basically explains the time elapsed since the capturing started for the packet to be received within this Wireshark application. And then we have the source. Source is basically that computer or that machine that initiated that request. Destination, as we know, is the destination of the request. And then we have the protocol through which that packet was sent. Then we have the length of the packet, and then we have the stream index. However, you might not have stream index as a column, but in the next video I would show you what is the purpose of this stream index, how to use it, and how to apply it as a column. And then we have a very basic information about the packet. And then we come over to this second group or second tab, which contains information which has been grouped into dissectors. So the very first dissector is frame. Now there is one important thing when you're working with dissector is that some of the fields are not encapsulated with square brackets, while some of them are encapsulated with square brackets. Now the thing is that the fields that have been encapsulated by square brackets are not the part of the packet data. It has actually been provided by Wireshark so that it can organize them in a better way. Most of the times when we are working with dissectors, we would be concerned with Internet Protocol version and the TSL version too, because through that we can find out the stream indexes and we can combine those streams to get the complete data of a particular request. And lastly, in the third column, we have some data that looks like garbage, but it's not actually garbage. It is the actual data that is contained inside every packet. Now, one important thing is that when you're trying to recapture some data, it is going to ask you whether you want to save the data that has been captured previously, or you want to start a new capture without saving the old data. So the choice is really up to you. Anyways, that was the basic introduction to Wireshark. Again, Wireshark is a network packet analyzer application that can be used to find vulnerabilities within a network. So now in this video, we're going to learn how do we capture data when we are surfing the internet or when we are trying to analyze a network. So the very first thing that I want to tell you is that if you have network capturing on, then all of the applications that are installed in your PC, even when you're not surfing the internet, are requesting some kind of data to their own servers. So that is why, even though I had started the capture but I was not searching for internet, I still had all of these packets. So you need to be wary of this thing, that even if you're not surfing the internet, your PC is still sending some data and still receiving some kind of data over the network. Now, what we're going to do is that we're going to open up Firefox, and then we're going to head over something like youtube.com. But I'm not just going to hit enter and visit YouTube. The very first thing that I'm going to do is that I'm going to start the capture, start it without saving, come over to Firefox and then hit enter. So that way, I'm going to capture every packet that has been communicated between my PC and youtube.com server. Once that is done, I'm going to stop capturing so that I don't get garbage data which is not useful for me. Now, within this whole section of packets, there are some packets that were communicated to my system or from my system to youtube.com. But if you were to just look at it with the naked eye, we cannot differentiate the packets which were from YouTube. So for that, we need some kind of filter or some software that can basically cut down these packets and give us only those packets that were sent to YouTube. We can do that with the help of filtering. Now, to apply a filter, you would have to come right over to this field. Now, in this field, we can apply any sort of filter. For example, let's start off with the protocol filters. So imagine that you are working with different types of networks and different types of data, and you want to organize that data depending upon the protocols. You want the data that was sent over the TCP protocol. So you would only type in the keyword TCP and hit enter. So that is going to filter these packets from TCP to others. And then as I have visited YouTube, I want to search for those TCP packets that contains the word YouTube. So I can simply go like TCP contains and then type in YouTube. Once that is done, I simply hit enter to filter my data. Now, from like tens of packets, we are left with only 3 packets that contain the word YouTube. So if I simply select one of them, and if I look over to the raw data, which is right over here, I can see that there is indeed the word YouTube present in this data. And the destination is this one. Now, it is pretty clear that the whole website of YouTube was not loaded with the help of these 3 packets. It must contain some other packets that were delivering data to us. We need to find those as well. Now, to find those, we need to search for packets that had this IP address within them. Now, to filter packets on IP address, we have this filter which is ip.addr, which stands for address, and then we put a space and then we put $= followed up by the IP address on which we want to apply the filter, which is going to be 142.250.13.198, and then we simply press enter. Now we have all of the data that was sent between our PC and youtube.com. So if you come over to the very first packet that was received, you can see that the source was our PC, because at first we were the one that initiated this request between youtube.com and our PC. And then later on, after 2 packets were sent, the source changed. It became the YouTube's IP address as source because we were receiving some of the data from youtube.com. And then even the protocol changed, and if you look at info, a handshake was established between youtube.com and our PC. Let's talk about stream indexes. Sometimes when you are working with packets, you want to know what is the stream of certain packets, because packets are not sent in a sequence, they are sent asynchronously, meaning that you send multiple packets containing multiple requests and then you receive them in a random order. Still, you want to combine all of the packets that are sent for a same or similar request. Now, we can do that with the help of streams. So as you can see that there is a stream index right over here which is 3. Now you might not even have the stream index as a column. To get that, simply open up TCP and you would have this stream index field in the dissector. Simply right click on it and then select this option that says apply as column. Now that is going to apply stream index as a column. We are going to learn about following streams in the next section, but this section was all about filtering and capturing network. Now let's try something as heading over to google.com and filtering data for google.com. So I'm going to open up my Firefox, I'm going to start capture, continue without saving, search for google.com, hit enter, and once the google.com has loaded, I'm going to stop capturing and clear out my filter. So this was all of the data that was sent within this time period. Again, I'm simply going to set the filter to TCP contains Google and then hit enter. And these are the 3 packets that were communicated between google.com and my PC. And if you look at the info, this says client hello web. We are basically trying to establish a handshake with google.com. Now we're going to filter all of the packets that were communicated between Google and our PC. For that, we are going to use the IP address. So the filter again is ip.addr, which stands for address double equals and then the IP address of our destination, which is 142.250.201.130, and then hit enter, and then we have all of this address. Now in the next section we are going to learn about how to follow streams, and then in the later on section we are going to learn what are the issues between HTTP and HTTPS websites. Because currently if you head over to Google, we know that Google runs on HTTPS, which is Hypertext Transfer Protocol secured, which means that the data right over here would be encrypted. Anyways, that brings us to the end of this video. So now we're going to talk about following streams and how we can basically summarize a whole communication process that has been done between 2 different sources. So what we're going to do is that we're going to start capturing in Wireshark, continue without saving, and then we're going to head over to Firefox, and then we're going to visit google.com. Now we know that google.com is HTTPS secured, so that is why we have this tiny lock icon, meaning that it is totally secure. Well, I will explain you the difference in this video. So next up we are going to visit youtube.com, which we also know works on HTTPS, which is secure. And then lastly, we are going to visit example.com. If you look closely right over to this icon, it has a little cross over it, meaning that it is not running on HTTPS, rather it is running on HTTP, which is not that secured, which is not encrypted. Once that is done, we can head over to Wireshark and stop the capturing process. Now, since I've shown you how to add the stream index to column, if not, come over to TCP, come over to stream index field, right click on it and use or select the option that says apply as column. That will give you the stream index as a column within this tab. Now what we can do is that we can simply search for or filter TCP contains Google, and over here we have this stream index that is 0. So if we want to basically combine all of the packets that were sent through the stream index 0, what we can do is that we can simply choose the first packet, right click on it, go to follow, and then simply select this option that says TCP stream. Now what this would do is that it is going to follow this TCP stream, and then it's going to combine all of these packets to make up a whole conversation. So now we have this whole conversation. So if we look right over here, we have 36 client packets and 19 server packets that were sent through this stream, comprising the whole conversation that has been done between our PC and google.com. Now, if we look over to the data, all of this is actually the real conversation that occurred between our PC and google.com. The one in the red or pink is actually the client data, which in our case is our PC, and the one in the blue right over here is actually the data or the communication that was made by the server, which in our case is actually google.com. And then we have again the client communication, the server communication, and so much more. But if you were to read this is a bunch of random letters, so we cannot compromise any meaning out of this. This is because this google.com was running on HTTPS, which has data that is encrypted. Now we have this option in Wireshark that allows us to change the encoding of the data, so we can change it from ASCII to anything else, but that is not going to change the encryption that has been placed on this data. So that is why we are going to leave it as ASCII. But in case you are analyzing a data that is not secured, that is not encrypted, and then you want it in some particular encoding, you can do that with the help of this field. Anyways, what we are now going to do is that we are simply going to search for TCP contains example.com. Now if I visit my Firefox again you can see that it was not encrypted. That is why we have this cross over the lock icon. So now if for example.com we did right click and then follow and then TCP stream, and one more thing, as soon as I click the TCP stream, you're going to pay attention to this filter. So follow TCP stream, and this filter changes to TCP stream equals to 23. And if we were to read this, we are somehow able to read the conversation that occurred between our PC and example.com. So the client request was a GET request. It was sent over HTTP, and the host was example.com. It was sent through Mozilla 5.0 using Linux 86 and 64-bit architecture, and so much more. So this is all of the information. Even though this is the entire conversation, we can still not get the data that was sent to our PC. Well, we have another follow stream that is known as the HTTP follow stream. So if we were to look for the protocol that says HTTP with the same stream index, then we are going to right click on it, go over to follow and choose HTTP stream. Now this time around, we would get the entire HTTP code of the example.com that was communicated to us by the server right over here. So that is how you can analyze the network, search for a particular domain, search for a particular packet, search for a particular stream, and check out the data, and then use the follow stream option, actually combine the entire conversation that occurred between those two servers, and then you can change the encoding to make the conversation readable. So that is how you can use the follow stream.